So now I'd like to look at an example. So let's take this one. This one has a heavy kind of cylinder here attached to the wall, or attached to the ceiling, sorry. And there's a string that feeds off of that to a block, and the block is released, causing the wheel to unwind. Now the wheel is very heavy, so it's going to go fairly slowly. So the first thing we want to look at is our signs, right? So the block is going to go down, which is going to cause the wheel to rotate counterclockwise. So let's just call counterclockwise positive. And right, if that rotates counterclockwise, which is positive, then this is going to go down. So we should call that positive as well, just making sure that we've linked those two so that they both have the same sign there. Right, we don't want the block to be going in the negative direction with the wheel to be going in the positive direction. That would kind of contradict itself. So we're going to be looking for the acceleration of the following block. So to do this, right, remember that we have a couple options available to us. So the first thing is we could sum our torques on the wheel. So sum the torques on the wheel is equal to I alpha. And then we need to think about, well, what forces are acting on the wheel that would apply a torque? So, and the one that comes is tension. So tension, right, the tension in the string is pulling down on the wheel, which is there for causing it to rotate. So that tension, that torque would be the force, which is tension, times by the radius, which we'll just call R. It would be 1.5 meters there. So we then need the moment of inertia. So the moment of inertia for a cylinder, we could go get this off of that, right, that page with all the different moment of inertias is 1/2 mr squared. So we'll go ahead and plug that in. Times by alpha equals TR. Now the other problem is, right, we're looking for the acceleration, A, and we have an alpha. So recall that A is equal to R times by alpha. So alpha is equal to A divided by R. So we'll just substitute that in. So there's a couple things that we can happen. We can simplify this down a little bit by canceling the r's. So if we note, we have an r in the denominator and we have two r's in the numerator, so we can cancel one of those r's. We also have an r on the left side of the equation and also an r on the right side of the equation, and there are only these two terms, so I can cancel those r's. So all of the r's are gone. So now all I'm left with right now is 1/2 m a is equal to t. Now, the problem is that we are looking for A, but we also don't know T, and we can't just assume that T is equal to mg. So we're kind of stuck right here. Luckily we have another thing available to us, that is we can sum the forces on the block here. So looking at the forces, we're going to have mg down and tension up, right? And again, not assuming that those things are equal. So we can now sum our forces on the block. This is for the block because it's moving linearly. So that's going to give us MA is equal to, let's remember that down is defined as positive, right? The positive sign is down there. So that's going to give us mg minus t. So we're trying to solve for A. So what we really want to do is be able to substitute that t in there. So we're going to just say t is equal to mg minus ma. And then we will take this and substitute it in there. So what that gives us is we have 1/2 ma equals mg minus ma. Now, again, we're solving for a's, so we need to get a's on one side of the equation. So it's going to be 1/2 ma plus ma. Oh, one thing I should note, that this is a capital M, and these are lowercase m's over here, because these are the masses of blocks. This is the mass of the cylinder. So that's going to give us little ma equals mg. So we can pull an a out of those. So you have a is equal to, or sorry, not equal to, a times by 1/2 big M plus little m equals mg. So a is equal to, and I'm going to go ahead and plug in the numbers right now. 3 times by 9.8 divided by 1/2, 6. So, right, we can just go back, right? The mass of the weight here is 3, and the weight of the cylinder is 6. So that's that, and you should get that your acceleration is 4.9 meters per second squared. So that's how you find the A. Right, just sum your torques, sum your forces, substitute the tension in, and then solve. So it looks a lot worse than it really is. Really, both of them are fairly straightforward there. So to solve for the tension, all you really need to do is take your tension equation from over here, the T equals mg minus ma, and then just go ahead and plug in the numbers. So that would be 3 times 9.8 minus 3 times y 4.9, and I believe, I actually don't have my calculator right now, but I believe you get 14.7 newtons. So, but you get the picture of how to do that anyway. So that is how you try to solve a problem like that.